everyone. First of all, I hope you all are staying home, staying safe, and doing great. It's been a while since I've delivered a talk at one of the meetups, um, and I also didn't get much time to polish this one, so we'll go slow. Now, if you have worked on any project that involves JavaScript at any level, at a medium scale, at a large scale, or even at a small scale, then there's a high chance that you have come across NPM and you have used NPM in order to install any node module uh, to leverage the capabilities that the node module exposes in your project so as to streamline and fast track your development process. Right. So in today's talk, I'll be talking about NPM vulnerabilities and we'll try to make a story as such. So in one of my past projects, I worked on a project which involves code scans right before building the application and publishing it to prod. So what these code scans do is that they scan your project code for any security vulnerabilities, and that's when I came across this concept of npm vulnerabilities in the first place. Before that, I wasn't even really caring about what these vulnerabilities are. But in projects where you have, in projects, especially in the banking domain, it's like a very big deal. And so today's talk is going to be about how you can find these vulnerabilities and how you can fix them. Uh, so yeah, if you're using npm, then there's a high chance that you've also come across things like uh, packages, so node packages, and these packages are declared. The ones that you will be using in your JavaScript project are declared in a file called package.json. So the package.json file would look something like this, wherein you have all the scripts, and then you have objects like dependencies and dev dependencies, where you define all the third-party JavaScript libraries which are exposed as npm packages or node modules that you want to use in your project. Now, npm follows something called semver or semantic versioning in order to version its packages. So as you can see here, there are versions like 9.2.0 or 9.0.5. These versions are semantic versions. So the way semantic versioning works is that there's a major version followed by a dot, followed by a minor version, followed by a dot, and then a patch version. So in this case, 3.9.2 is the package version, but the major version is 3, the minor version is 9, and a patch version is 2. So a major version would be any change that might break the ecosystem if somebody is using your package as a dependency. So this is something that we very less frequently do. Then we have minor versions. So we quite frequently update the minor versions, and minor versions contain changes like backwards compatibility, enabled new functionalities, or refactoring code which is large. So you might want to refactor or improve performance of the code by making it more better in terms. Uh, and then there can also be old functionalities that you might want to deprecate. And so all these changes are released as a part of a minor release. And then there's a patch version, which means that this would only contain any bug fixes that you might have done in your project. So this is what semantic versioning is all about. But in the package.json, you might have also come across these two different signs that are the caret symbol and the tilde symbol that you specify. What the caret symbol does is it allows npm to install any later minor version or a patch version, keeping the major version same. And the tilde symbol only allows npm to install any later patch version, keeping the major version and the minor version intact. So what that would mean is that if you're using let's say moment.js, and moment.js at the time you're using it is at version 2.0.0. If you have supplied the tilde symbol while specifying moment.js, then whenever the next time you run npm install and there's no package -log.json, then npm is going to install any version of moment with uh, 2 as the major version. So it's going to change the minor version and the patch version, but it will the major version stay and it would stay intact. So yeah, that's what this whole semantic versioning is all about. Now again, coming back to npm. So whenever we are using npm, you might have come across a few of these things. So one of them is the package.json that specifies all the dependencies that you might have in the project. Then there's a node underscore modules folder. And this is the folder where any dependency you might have in your project gets installed to. But there is also this file called package-log.json or yarn.log file. So what exactly does this file do? Uh, so yeah, this file is going to be one of the major things that you might come across, especially when it comes to dealing with vulnerabilities. So in this project, I don't really have moment.js installed. So if I search for moment in here, I won't find anything in the dependencies object as such. So what I'll do is that I'll install moment. And at the moment, I've checked that moment is on version 2.29.1, but I'll install 2.0.0 version of it just to give you a sense that this moment library was installed uh, at a past instance, right? So now I have installed moment 2.0.0, and you will also see that the moment was added as a dependency in package.json's dependency object. But you'll see that there's a caret symbol in here. Now, as we have already discussed, the caret symbol would mean that whoever clones this repository at a later point in time and then runs npm install, if there's no package-log.json, then it is going to install whatever version is latest at that time, keeping the major version intact. So it might install a version like 2.29.1. Now, even though these two libraries or these two versions of moment don't have any breaking change, but they still might have uh, different versions or different behaviors, right? So if you're using moments, two different versions in two different instances of the same project, then you might come across a scenario wherein your application is probably behaving in two different ways, right? So in order to fix that, there was this file introduced that is package-log.json. Now, if I open up the package-log.json, then you'll see that let's search for moment in here. You'll see that for the moment package, it locks the version as 2.0.0. So now, even after 1 year, keeping in mind that the package-log.json file was pushed to or committed to the source control. If somebody else tries to clone this repository and runs npm install, then on their machine as well, uh, the version of moment that's going to get installed is 2.0.0 instead of 2 point something, right? So that's what the package-lock file is all about. It's all about keeping the behavior of the application consistent across the board, right? Okay, now coming back to okay, coming back to the slides. So yeah, this is what package-log file is all about. Now, we live in a world in a developer ecosystem where the JavaScript ecosystem is quite rich, and you always come across a package that is already there in place, so that you don't have to reinvent the wheel, you don't have to start something from scratch, right? But with all that advantage also comes in this disadvantage of vulnerabilities, because even though there are a lot of good libraries out there, but that doesn't really mean that they are secure, right? And so if you are installing and using one such library, then it would also lead your applications vulnerable to all those vulnerabilities that these third-party node modules have, right? So how exactly can we deal with these vulnerabilities? Well, since npm packages are mostly open source, a lot of people out there raise issues and vulnerabilities in these projects, and then whenever these vulnerabilities are addressed, a security advisory is published for these particular packages, and then these security advisories are added to npm's security advisory database. And if you go to if you go through the details of any security advisory, then you'll get a lot of details about that particular vulnerability. So things like what's the severity of that vulnerability, what exactly is that vulnerability all about, what package does it affect, overview information, any remediations that you might want to try in order to fix that vulnerability, and any different versions other than the current version that this vulnerability affects, right? So we already know that in our source tree, we have these specific packages that we are using through the package-log file. And we also have this advisory database that gives us all the different information about different packages that might have different versions and which specific versions are vulnerable to any security vulnerabilities. So keeping all that in mind, you can query this database, give it the information regarding your source tree, and then get the details of which specific vulnerabilities that you have in your project. And in order to do that, since npm 6, there came in a command which is called npm audit. So you just run npm audit. What it does is it submits a description of all the dependencies that you have in your project to some sort of a default registry, and asks it if there are any vulnerabilities. And if there are any vulnerabilities, then it also gives you some sort of remediations for those specific vulnerabilities. So let's say if we run npm audit, then you'll see some sort of an information that looks something like this. So let's try doing that, and let's try running npm audit in our project. So I'll close all these files. I'll run npm audit. Let's make the screen bigger, and let's wait for it to run. So as you can see, it lists down all the different vulnerabilities that you might have in your project. And there's details like what's the severity level, what exactly is that vulnerability all about, what package does it affect, and if there is any patch available for that particular vulnerability or not. If there is, then what's the version on which it is patched? What is this package a dependency of? And so on and so forth. And there's also the security advisory details that I was talking about. Let's try and open this up in a new window and see what this looks like. So yeah, it gives you all that sort of information. So now that we know that there are these specific packages in our code that are vulnerable, how exactly do we fix them? So that's also pretty easy, actually. You can just run the npm audit command. Let me just clear it. And yeah, so you can run the npm audit command with the fix argument. And once you run that, it is going to run npm install under the hood, because it is going to then install different versions of different packages as per the remediations that are provided to us by npm's security advisory. And so yeah, that's exactly what it is doing at the moment. Now before checking in, I think we had somewhere close to 350 vulnerabilities as such. And now it's running npm audit fix. So let's see how many vulnerabilities do we get once this happens. All right, so it's almost done. So yeah, it gives you all that sort of information as well. Most of this info that you're seeing right now on the screen is also something that you see when you run npm install, right? So yeah, npm audit fix does run npm install under the hood, and it says it also gives us this information as to it ran the fix command for these specific scan packages against, and these are the number of packages that it has fixed automatically. There are a few packages that are still pending to be fixed. So let's try running npm audit once again and see what all these packages are and why did it not fix these packages. So in most of the cases, these packages are not fixed automatically because there is some sort of a breaking change that might be introduced if you try to fix it using npm audit. You can still use the --force flag in order to then install these, but then it might lead to a breaking change in your project and your project might not work as expected again. So that's why we have to then think about different strategies that we can use in order to fix these issues. So, right. So yeah, we have talked about npm audit. Um, we can use the npm audit fix command as we have already seen. But after that, how do we manually intervene and fix the remaining vulnerabilities that we have? So we now have somewhere close to 13 vulnerabilities, out of which 5 are low, 1 is moderate, and 7 are high. Usually, what happens is that most of these vulnerabilities that you'll find are somewhere they are mostly transitive dependencies, as in dependencies of dependencies, right? So you might not be able to directly make changes to your package.json file right here in order to fix these, right? So what exactly can be done in that case? So we first try to identify what exactly is the vulnerability all about and how can we fix it. Um, Sorry, I'm pretty new to Mac. So uh, yeah, okay, let me just run npm audit once again. And all right, so these are all the different vulnerabilities that we see. Most of them are related to Node4j. So let's open the advisory that is present here and see what it is all about. Okay, so there is something related to denial of service, and the severity is low. But still, if it is low, if you pass this through code scan, then you might get a failed report, and then your project lead might not allow you to go ahead with the deployment. So you still have to fix this. Um, the good thing is that it also has the remediation for this vulnerability, and so there's this thing wherein it says that you have to upgrade to version 2.6.1 or 3.0.0-beta.9. So let's try running this project and installing 2.6.1 in the project. But before doing that, let's open up package-log file, and let's try looking for uh, node-fetch, right? So I'll look for node fetch. You'll see that it has 2.6.0, somewhere it's 2.6.1, and so on and so forth. There's 2.3.0. So in most of the cases, you'll see that the major version is still the same, even though the minor and patch versions are changing. So we can safely change it to version 2.6.1, which is specified here, without breaking anything as such, right? Now, if it was present uh, as a dependency in our package.json, then we would have easily been able to make that change here, right? But that's not present here. So how do we make make that change in package-log.json? And tell uh, our dependencies that they have to use this particular version of Node-Flex. So that's where resolutions come into the picture. So there is an object called resolutions, and in this resolutions object, you can specify specific versions of specific dependencies that you want Node to resolve for you instead of the ones that are present in the package JSON files of those dependencies, right? So yeah, the package that we have is node-fetch, and this is that specific version that we have to resolve to. Now, this won't work out of the box, and there's a specific package that we'll have to use in order to enforce these package resolutions for us. And the name of that package that we use is npm force resolutions, right? So we will have to use this particular package in order to make it work. So in order to do that, what I'll do is I'll just create another script in here and call it, let's say, resolve. Some people also tend to create like a pre-installed script and then use this in order to run it. But yeah, now I don't want to install it. I just want to run it. So I'll use npx in order to do that. And let's copy this. Okay, it doesn't copy for some reason. Okay, copy it that way. Save. And this time around, I'm going to run a command called npm run resolve, which I've just created. Let's save this. And before running this resolve command, we had somewhere close to 13 vulnerabilities. So if I now try and run npm audit, let's see how many vulnerabilities do we have. So it got rid of 2 vulnerabilities that were related to node fetch. Now, for all these other packages that we have, we'll have to do something similar, wherein we first check if there is any security advisory related to it, open it, then check for the remediations that are provided in here. It says that we have to upgrade to version 0.10.0. So I'll copy that and then go back to the package-lock and check node forge. This says 0.8.0. This says 8.5, 0.9. So yeah, it's safe to then install any specific version where the major version is still 0, right? So I'm gonna do that for node forge as well and save this. Let's try running npm audit once again. Sorry, npm run resolve once again. And it is going to then resolve to 0.10.0 version of node forge. So if I run npm audit once again, then now we have 7 vulnerabilities. And I'll continue doing this as long as I can. And I've already done it, so I'll probably just paste in these specific versions of resolutions that I want my project to apply. So I'll save that, and let's finally run npm run resolve once again. And if I now try to run npm audit, I now have 0 vulnerabilities. And so I can definitely give this particular project to the code scan team. They can scan it. They will probably not find any vulnerabilities in there. And that's how we get a green signal for going ahead with the deployment, which is great, right? So yeah, these are all the steps that we talked about so far. again, I'll go through this process once again of how we can apply these resolutions. So in order to apply the resolutions, we use the npm force resolutions package, and then we run it directly. But this runs on a resolutions object that you provide in the package.json, and these are all the resolutions for those specific versions that you want npm to resolve to. And then we just run this command that we have here. So yeah, that's how it is. Now, one last thing before I close is that there is um, there is a bot that does this automatically. So what this bot does is it checks for vulnerabilities in your package and in your project's package.json, and it tries to determine if it can do something about it, right? So the name of this bot is Dependabot, and you might have also seen it somewhere on GitHub. So what it does is it creates pull requests against your projects, and patches them with any specific change that it feels might fix any issues. And I think this was on this exact same project. So if I open up my Chrome and go to github.com/, okay, and yeah, so you can see in the pull request section, all these pull requests, all of them were created by Dependabot, right? So yeah, just something that I thought was pretty cool. Uh, and yeah, so that brings me to the end of the talk.